developing robots for remote inspection, so often there's a drive to send a robot rather than a person in to do an inspection because it's maybe dangerous, a confined space, there might be radiation, other challenges. So send a remotely operated vehicle into things like service trenches, might drive along half a kilometre, take several measurements and things. One of the challenges with sending robots is if they don't do a very good job, it can actually be quite dangerous because they might not do a good assessment and then the facility can fail. So we're trying to make the robots as capable as a human inspector. And a few ways we're doing that. One is that we're giving the robot kind of cameras all round. So a human can wear a VR headset and look round in 3D and really feel like they're in the trench, so give a very good proxy for visual inspection. And we've also incorporated a little robot arm onto the robot, so the operator can then control the arm and can do things like clean the surface, take ultrasonic measurements, and take radiation measurements, things like that. So all of these things will hopefully make the remote inspection much closer to human inspection and much more accurate and lead to better safety, etc. Really a lot of it's about removing the faff from the robotic system. A lot of these systems are quite cumbersome, hard to use, take quite a lot of training. Our systems uses kind of AI and intelligence to just make it a lot easier to use. Things like controlling the robot arm and kind of piecing together all the information. Strathclyde motto is the place of useful learning. We want to do research that gets used by industry. So we're very keen to see our technology be developed up the TRL level scales, technology readiness scales, and deployed on site. So we'll be working with engineers from Sellafield to try and deploy version 1 on site and actually get some value out of that. And then we'll keep developing the technology to make version 2, version 3, etc.